build on what Doug and Barbara were talking about with some of the specifics on our project about how we're building the game, going past the design point because our process is very similar to the one that Barbara just outlined, and give you some insight into how we're doing it because it may be helpful for you. I was thinking yesterday during lunch about the idea of some of these formative products that we have that we create these things as we're doing our projects, and they're unique to our projects and really could be valuable if they were shared long before it has to be something that's evident in a report that's distributed somewhere. So the federal government has established a training program for people to learn to use STEM skills to become survival masters. And they're going through these training programs, and then they can go out like MacGyver to some kind of disaster, Katrina, Haiti, and use STEM skills to solve problems. So these training centers are situated in different geographic areas. The game that we happen to be building is one that's situated in Alaska, and it's a game for training winter survival. So the game that we're building is a game that's a STEM infusion of a collection of grade standard learning activities into technology education. So we're working with new curriculum. The curriculum does not exist. The team is designing this curriculum to be used for the first time in STEM education for 8th graders. And it's a replacement curriculum. So this project is to be taking up 3 weeks of class time in a technology education class. So in the game that we're making, we have a single player portion of the game, and there's 4 levels in the single player, and they have experiences for the students where they work with, at one level, the first is a diagnostic for math, volume and surface area calculations for simple geometries, then a level for heat flow, then a level for R value, and then a structural assessment level. In the design of these levels, the first level is a match puzzle kind of a game mechanic. The second level is a platformer. The third level is an action race game, and the fourth level is a construction game. After the players have finished going through these training activities that they have to do on their way to becoming survival masters, then they're formed into teams of 4, where they have to actually use these skills as a capstone in a RPG multiplayer, and they have to build a shelter that's going to have sufficient heat flow and also withstand a specified snow load and wind load. And these shelters are, as part of the multiplayer RPG play, are actually engineered. So there's an iterative, informed design process that they have to use as they go through the process of building these shelters. So our team, 25 months ago, started working on the project, and the game that we're building now is significantly different than where we started 25 months ago. In fact, they bear very little resemblance to one another. So this particular game is, as you can imagine just from listening to the list of gameplay, this is a pretty substantial product. There's a lot of curriculum, there's a lot of learning activities, and there's a lot of gameplay. Our focus, intently, has been on developing player choice, so that the player has a high degree of motivation when they're working as a single player to be developing their persona, accumulating the most valuable commodity, which is energy, and then also accumulating achievements like you would in an entertainment game that are part of their profile. In the end, there's going to be an opportunity for them to compare themselves to other players in the class by way of a high score table, and also for these teams that are going to be able to compete the same way. So that's their inherent motivation from the game. As part of the choice, they get to configure their avatar, and then they also elect a role. And these roles are based kind of loosely framed on Marvel's player suits. So a Lynx has more energy and refills, regens energy quicker. A Marmot can see the energy levels of the other players in the team and help coordinate the amount of work. Because when you move, carry, build, that expends energy, so try to even that out so no one's doing an unfair amount of the work. The falcons can see materials from farther away. It's a big game space. You have to go find materials to bring them back to build the shelter. And then lastly, the bear carries more weight. There are some inherent challenges in our project. So as I mentioned, when we started, we did not have a curriculum. So I assume that many of you, and many of you I've talked to, are in some way involved in building some kind of educational game or simulation that supports education. The idea that you would be able to, in a short time span, build a game while you're also at the same time framing the curriculum was a pretty significant challenge. Normally you'd have the curriculum done beforehand, and you'd have a pretty good idea of what the learning objectives were that you were trying to get your game around, and in this case, we didn't have that situation. Our research project is comparing this curriculum being used in a traditional mode in the classroom to a group of players playing the game and doing the exact same curriculum in-game. So as the players in the game are going through these knowledge and skills builders levels to learn about heat flow and structural analysis, students in a traditional classroom are actually doing that on paper and with their hands and building models and experiencing the traditional kind of way that you would teach that. And then in the end, the culmination activity is done the same way. The players in the game have to build a shelter with their avatars to survive. The players in the traditional environment, they're going to actually build a model, scale model, and then test it to see if it meets the slope. When we started, this was going to be an online multiplayer. So this was going to be completely web-based. We were going to have a lot of advantages from doing that, and you've probably played online multiplayers yourself before. Maybe you're already doing products that are online multiplayers. As you can see by this graphic, it's not an online multiplayer anymore. This is a LAN game. So in this LAN game, the students are connecting behind their firewall in the classroom, and we're using XML as the database, so we don't have the big full-blown SQL services to leverage for all of the data services that we need for the game. Instead, we're using XML. And this is part of reflecting the technology reality that we were confronted with, and that is in most classrooms, especially at the middle school level, the IT department is not going to open up the ports that allow you to speak to your game server and connect. So this is a reality-based response to that. So this is our work chart of our team, and that's kind of what I wanted to talk about was how our team is working, who we are, and something of a unique process that we have for actually making the game. So Mike is our project director and also the executive producer, and I'm the producer developer of the game. And the team is divided into 5 functional units. So we have an instructional research functional unit. We have a group that's doing cinematics, both cinematics for marketing and also cinematics that we're using in the game. Then we have a game design group, and that's a combination of instructional designers who also have game development experience. Then we have a level designer who happens to be an engineer, so he's a content expert, but he also happens to be a simulations designer. So he's been invaluable in helping us make sure that when we use the physics engine in the game to do something that's supposed to be representative of some kind of science, that the representation is in fact scientifically accurate. And then we have our art group. So geographically, none of these people are in the same place. So I'm in California, Mike is in Albany, New York, David Shaw is in Buffalo, the research team is in New York, the game design, instructional design group, they're at Bloomsburg University in Pennsylvania, the level designer is in North Carolina, and all the artists, except for one, are in California, but we're not all in the same place, so we're also spread out all over California, and we have been since the beginning of the project. So we work virtually. We work virtually on a daily and weekly basis. And the tools that we're working with, in as much as it's possible, are tools that are open source. As an example, the platform where we commonly share and communicate non-game assets is our Moodle learning management system. And one of the things that we've done is we've developed a QA system, a quality control system, that is part of our Moodle that we could share and give to anyone that was interested in using it. And we're using that now instead of DevTrack or any other kind of expensive bug tracking. It's actually just a component of Moodle that we're using for our quality assurance. So I wanted to kind of get to this slide as quickly as I could, because this slide represents our production model, the way that we make the game. So back in the day, not that long ago, the ADDIE model of designing instruction, analyze, design, develop, implement, evaluate, maybe that's right, pretty much a waterfall way to work. You don't go backwards. And of course there's always recursive feedback loops that no one ever does, but it's really waterfall. So you do your analysis first, and then you do your design, and then you do your development. And you would never begin your development before you were done with your design, and you wouldn't begin your design until you were done with your analysis. Waterfall was the way that entertainment games were developed for a long time, and that's no longer the case. About 5 years ago, Agile production has become very popular. A specific kind of Agile production called Scrum, S-C-R-U-M. It's not an acronym, it's a metaphor. Like the game rugby, you form a scrum, and then together in a small group, voluntarily you form to move and make some progress, and then you disband. That's the metaphor for the production model. So this is representative of Scrum, and Scrum is how we're organized. So, very quickly, grotesque oversimplification in Scrum. You identify the tasks that you want to do, and you put those all in a group, and you call that backlog. Then you have those tasks into groups that are standalone enough that they can be constructed by some members of the team, and then they can be evaluated. And in Scrum, those are called stories. So the smallest task unit is called a story. And then the amount of time that you spend working on something is called a sprint. So the way that we work is we have a backlog of many hundreds and hundreds of backlog items. And we identify, here's some pretty important backlog items that we think that we should work on. And then each of these subunits in the team, in their own functional areas, will have a sprint that they'll go on. And that sprint might last a week, it might last 3 weeks. Very rarely would it be longer than 3 weeks. And what they're going to do is, they're going to take this backlog task and they're going to go do it. They're going to develop this curriculum object. They're going to spend 2 weeks developing this curriculum object. Then they're going to come back to the team in that 2 weeks, and they're going to present their work, called the Scrum Review. When they present their work, everyone in the team meeting, every single person on the project, has an opportunity to contribute their input on how they did. Is there something that could be done better? Is this good? Is this bad? Where does this need correcting? So the idea is that you have this backlog, and then you have the amount of time. Of course, you still have time and budget, so you can't do anything about that. You have to work within those constraints. So that's telling you how much time you can spend on a sprint. And you're going to keep a report as the producer that's telling you, okay, this is how much time I have, so we can't keep re-sprinting things. If a sprint is done and someone presents their thing and it's not suitable, we can only spend so much time remaking things because we still have the reality of time and budget. But what it allows us to do is to work on things in what seems like a very chaotic kind of a fashion. So it's definitely not linear. You may have the art team decide, you know what? We want to work on this assembly for the multiplayer, which no one has even seen yet. We don't even have a first playable prototype. We want to work on this thing for the multiplayer because we think it's going to help us identify what the characters' actions should be like in these single player levels. So then they'll go off and they'll do that, and then they'll come back and they'll present it to the whole team. One of the things that's interesting about using this recursive, iterative sprint process is that you get this kind of feedback from people that aren't in the functional units that are looking at it with a completely different lens. So you're presenting this thing that you worked on really hard, you totally missed something, obviously, everybody else. And they immediately go, well, what about this? And then everyone goes, oh yeah, that doesn't work, does it? So, in using this agile production method, this Scrum production method, it's allowed us to respond as developers to changes in the curriculum almost on the fly. And that's all been based on play testing. So if you have a curriculum object, you think that you have designed it well, and you have a first playable where you're going to go out and see how that works in the hands of the players, and then they poke it a lot different than you thought that they were going to, or they really enjoyed playing it, no one learned a thing. You don't have this long process where you have to re-engineer things. All it's going to take is a sprint. Okay, here's what we're going to do. We're going to change this thing, so the curriculum's going to change here, the assessment's going to change there, this mechanic's going to change here, this script is going to change here. Everybody has a sprint that they're going to go on with their own story that they're going to work on, and come back in a week or 2 weeks and then reassess it. So then how we do this is we meet on the web, we use Acrobat Connect, and we share all of these things in our sprint review. And then we have a Moodle where we put all of this stuff from our sprint review. So anyone that has any interest in visiting the project can come in and you can look at our Moodle and you can see everything that we've done in this project in terms of production and development and game design for the last 25 months. So I think that this is a methodology that very much builds on the idea that Barbara was presenting about the interaction, the importance of the interaction of the typically disconnected members of a production team. Because in this kind of an environment, everyone has a chance to weigh in, everyone's required to be there, meeting times are held short intentionally so that everyone feels like this is an important thing that they can always fit into their schedule, and then this is the fastest way that we can get kind of a response to demand. So we have a website, same name as the panel, Gaming2Learn, gaming2learn.org, and we would, I have some cards that have that URL on it. I'm sure you're welcome to them. Number 2, Gaming2, the number 2 Learn. And we would love to have you visit the website. The curriculum is there. We have presentations and all kinds of media. And anyone that's interested in working with we're getting ready to pilot in January, that's interested in playing our alpha and beta levels, now we'd be happy to distribute those too. Thanks.